So what do you understand by mutually exclusive and exhaustive?
So mutually exclusive means that none of the elements are common to each other.
None of the element intersection is phi. Okay.
Intersection is fine. Yes.
And exhaustive?
It contains all the outcomes.
Mathematically, how do you represent that, Ritika?
So equals to sample space.
Yes,
If
sir.
you take the union of the events, then it becomes the sample space. Okay. Now I have a doubt. What will happen to the case if I consider n number of events? How do you write that mutually exclusive and exhaustive? Anybody?
Mutually exclusive, we will write like, for example, we are having even E2, E3 events till En. Then we should consider two variables such that Ei intersection Ej should be 5, where I is not equals to j. Mutually,
Have I discussed that?
yes, sir.
Okay, then let us proceed. Okay, I thought I missed that part. Anyway, so yes, in case of n number of events, it is written like this that everything for I not equals to j has to be empty. Okay, and union of all those things, events 1 to n, becomes your sample space. Okay, then we call those E1, E2 up to En as mutually exclusive and exhaustive. Right. All right, fine. Let's go to the next part. Okay. Today we are going to discuss some basic definitions of probability. Have I discussed equally likely? No. Okay, tell me, how do you define equally likely cases or equally likely events? It is there in the PPT. You can see two events are said to be equally likely if and only if. Okay, one of them doesn't get the preference of occurrence before the occurrence of the other one. Okay, that means, for examples, we can say that when a fair coin is tossed, the probability of getting head and probability of getting tail remains the same. That is half. Similarly, if you roll a die, okay, then probability of getting each face is 1 by 6. Okay, so probability of getting face 1 is 1 by 6, 2 is 1 by 6, and so on. 6 is also 1 by 6. So those cases are considered to be equally likely. Okay, next we will discuss the classical definition of probability. Okay, so when I say classical definition, basically we need to understand here what do you mean by that. Okay, so basically there are three definitions of probability. One is the classical one, another is the frequency approach, which was proposed by the statistician, and another was the axiomatic approach proposed by the scientists. Okay, so we are going to discuss the two approaches, that is the classical approach along with the axiomatic approach. We will not discuss the frequency approach, that is not required. Okay, so what is classical approach then? What do you understand by classical definition of probability? The one which one you used to continue, I mean from your high school or from your plus 2 level, that is known as the classical definition of probability. Okay, and this is the definition in front of you in terms of PPT. That okay, and what is that? If E is a random experiment having m possible outcomes, and those outcomes are exclusive, exhaustive, and equally likely. Okay, and I'm defining one event A, and A has n number of favorable outcomes. then the probability of the event A is defined by number of favorable outcome to the event A divided by the total number of possible outcomes for that. Okay, I hope the definition is clear and very much known to you. Everybody, is it okay? This was the definition. Okay, and you know this thing maybe from your high schools, right? Now, next comes to the properties of this probability. Okay, remember that every time if we talk about any event E, first and compulsory property is that the probability of any event is always within 0 to 1. It will be 0 in terms of null event, it will be, or impossible event, you can say, that we had discussed in the last class, and it will be 1. I mean, probability of the event will be 1 in case of certain events. Okay, for others, it will be always within 0 to 1. Okay, next, if you are having k number of mutually exclusive and exhaustive events in the sample space of an experiment, then the sum of all those probabilities of experiments becomes 1. Okay, in short, we call it as sum of all probability must be 1 in any experiment. Okay, the sum of all probability must be 1. Okay, next is known to you that probability of an impossible event is 0. Last one is also trivial, that if E1 is contained in E2, proper subset of E2, then probability of E1 is always less than or equals to probability of E2. Okay, so these are the 4 things, out of which property 2 and 3 are very much important and we will use in the subsequent classes. Okay, any doubt? सब सो गए.
Sir, can you please repeat fifth property?
Fifth property. Fifth says that if E1 and E2 are two events and one is contained in other, one is a proper subset of other, then what is the relationship of their probabilities? Probability of E1 is always less than or equals to probability of E2. Okay. Next, we'll come across the next approach of probability, and that is called axiomatic approach. Okay, now first thing I would like to know, what do you understand by axioms? How is it different from theorems?
Sir, axioms have no proof as such, they are just truths.
Yes, axioms do not have proofs. Okay, theorems have. I mean, theorems we have to prove whether they are true or not. Okay, we need a general proof for theorems, whereas axioms are basically required in order to, I mean, define a concept. Okay, they don't have any proof. Okay, so here we will discuss the axiomatic approach of probability, and it says that let S be the sample space and P be the real valued function and A is an event in the sample space. Then probability of A is denoted by P of A. Okay, and first axiom says that for any event A, the probability of A is always within 0 to 1. This is called axiom of non-negativity. Okay, next one is axiom of certainty, which says that probability of sample space is always 1. And 3 says that if A and B are mutually exclusive, what do you understand by mutually exclusive? When I say mutually exclusive, what do you understand? Mathematically,
Two disjoint events.
A intersection B is
5.
phi. Okay, and probability of A intersection B becomes 0. A intersection B is not 0. A intersection B is phi. Okay, and hence the probability of A union B becomes PA plus PB. That is called axiom of additivity. And in the fourth axiom, this third one is extended to infinitely many mutually exclusive events. Okay. So first one, remember that axiom of non-negativity. Axiom of non-negativity means probability of any event is always greater than 0 and less than or equals to 1. 0 होगा in case of impossible event, 1 होगा in case of certain event. So combining these two, we will write that PA for any event is within 0 to 1. Is it okay? This is called axiom of non-negativity. Okay. Next one says that probability of sample space, it is 1. It is very much clear from the definition itself. Okay. Third one is coming from the probability of A union B. Okay. Can anybody tell me what is the formula for A union B in set theory?
Probability of A plus probability of B minus probability of A intersection B.
Okay. In set theory, it is A union B mod becomes A mod B mod minus A intersection B mod, right? Here just we are incorporating probability instead of mod. Okay. This formula is called your addition formula, or you can say addition theorem. Okay. And when A and B are mutually exclusive, we will say that A intersection B becomes phi, or the probability of A intersection B becomes 0. And hence, what will happen to A union B? It will be only left with PA plus PB. And what you call it? Axiom of
Addition.
addition. Okay. In the fourth axiom, we extended this concept to n or maybe infinitely many. Okay. That means if a1, a2, and so on an, or and so on again, I mean infinitely many, okay, are mutually exclusive, then the probability of all those unions of infinitely many events becomes the sum of the individual probabilities of the events. Understood? This is just the extension of the third property. Okay. So this is your definition of probability based on axioms. Okay. Next, let me go to the PPT. मैंने अभी बोर्ड शेयर किया था या PPT?
जहाँ बोर्ड
ओके, करेक्ट. कभी कभी कंफ्यूज हो जाता हूँ. ठीक है. Anyway, next I have enlisted some of the properties, trivial properties. Remember here, okay, there are several approaches to prove these statements. I have taken one approach given in the book. Okay, you can prove them through several approaches. Okay, go through that one which is convenient to you, nothing else. So if A and B are events in the sample space S such that A is a proper subset of B, then PA is less than equals to PB. This is there in the properties of probability. Okay, here is the proof. Next, if A and B are two event in the sample space S, then probability of A minus B becomes PA minus P of A intersection B. This is known to you from the definition of A minus B. Okay, it is also very much trivial. And here is the addition theorem. Just now we have seen. Okay, so remember the name. You know the formula, but Sometimes it will ask the prove the addition theorem or so use addition theorem to prove this. Okay, अब बोलोगे addition theorem क्या है? This is only addition theorem. Okay, this one is known as your addition theorem. Now, thing is that can anybody extend this addition theorem to three events A, B, C? What I mean to say, I want to know the formula for probability of A union B union C. Anybody?
PA plus
Probability of A
PB
plus probability of B plus probability of C minus probability of A minus probability of AC minus probability of plus probability of ABC.
Okay, Ayushi, when you say A, B, what does it mean?
So when A and B are when A and B are in union of A and B. So union is intersection of A and B.
Okay. Abhishekta, you want to modify or is it correct? Hello?
No, sir, I think it's
Okay. All of you, is it clear? Not clear. Okay, let me write. Okay. Let me go to the Jamboard. Let me write the formula. All of you note it down because that formula we need in order to solve problems. Probably you are going to get a question, maybe in the midsem or endsem related to that. All right. So it says that if ABC are three events, then probability of A union B union C becomes PA plus PB plus PC minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C. Anything else?
Plus probability of
plus
C intersection of
yes.
Yes, correct. Okay, so this is the formula for three events. Okay, it has a generalization. It can be extended to n number of events as well. Okay. Okay. Then again the condition arises. What will happen to this formula when A, B, C are mutually exclusive? What will happen to this formula, the above formula, when A, B, C are mutually exclusive?
and then only
The intersection probabilities will become 0.
One at a time. I could not get. ये क्या है बोलो बोलोगे तो दोनों एक साथ वरना कोई नहीं
That the intersection will be removed. We'll ignore it.
this term
Yes. All three.
this term will
Yes.
get 0. Any other?
The last term also.
The last term also. Okay, and hence the formula reduces to A union B union C becomes PA plus PB plus PC. Okay, which is nothing but a part of this. Okay, so these are the basic things that we need to know. Okay, now let me go through the book. No, before going to the book, make a heading, write down. You need to know the concepts of set theory. So I hope everyone is clear with the Venn diagram. Yes or no? Only one yes, sir.
Yes, sir.
Rest
Yes, sir.
71.
Yes, sir.
Yes, sir.
Okay. All right. So when it is yes, sir, for so many, Let me put some question. I'll ask individually, and those have to answer. Okay. I'll draw the diagram. You will have to answer me what it represents in terms of set theory. I will ask one by one. Don't say, I mean, okay. So who will going to answer this one? Let me go through. Okay, lucky one. Tanmay 1354. Hello, Tanmay 1354. Okay, Tanmay is absent for today class. Okay, let me end this. 1354 absent. Okay, next 424. Pragya. Hello, 424. 1424 absent. 2376. Vaishnavi.
Yes, sir.
Okay, Vaishnavi. Could you tell me what this highlighted part indicate in set theory? If let me give proper information. If I will take this one as set A, this one as B, can you tell me what is the highlighted part?
It's a union of A and B.
Very good.
Sir, A intersection of B.
A intersection B, sir.
Sir,
A
A
intersection B.
तो फिर मैंने very good क्यों बोला था? Anyway,
So
क्या बात है? आपने नर्वसनेस में बोला या जानबूझकर बोला या फिर नहीं पता था सच में? Anyway, okay, let me come to 540. 540.
Yes, sir.
Okay, you tell me what this part will represent. Only the yellow highlighted part.
B minus A intersection B.
Okay, so your friend is saying that this is B minus A intersection B. Is it correct? Everybody, is it correct?
No, sir.
no, sir.
Sir,
No,
it's
sir.
minus.
No, sir.
Okay, what is then? What is the correct one?
It is
Sir,
normally
A
A.
minus
A minus
A minus
intersection
A
B.
minus S intersection B.
A minus A intersection B.
A minus intersection B.
So A intersection B complement.
Okay, so just a minute. Let me change. हाँ, A intersection B complement एक आया और क्या आया? A minus B.
A minus A intersection
A
B.
minus A intersection B.
Okay, A minus A intersection B. Okay, can I write A minus B as well? No.
No, sir.
Then what is this one? This is the same, na? A minus A intersection B and A minus B both are same, na? In terms of set theory or in terms of word, this is known as only A. How do you compute only A? Only A can be done by A minus the intersection part. And it is similar that A minus B, because A minus B can be defined. If I write X belongs to A minus B, it means the elements must belongs to A, but it won't belongs to the B part. Okay, so this is equivalent to this one, but the thing is that in probability we may not get formula for this directly. Sometimes we get, okay, but this thing can be done. Okay, we will have the formula for this. I mean, this can be easily evaluated through the probability concept. Okay, चलो अच्छा लगा आप लोग का आंसर जान जानकर. So this is A intersection B complement. It can be told as A minus A intersection B, or it may be A minus B. Okay, next part. Similarly, I hope this part can be
Only B.
only B, or you can say A complement intersection B. You can say B minus A intersection B. Likewise. Okay. So all right. Now the whole part. The whole part.
A union B.
Union
Sir,
B.
A
A
union B.
union B.
Okay. Okay. Correct. Now, which color should I take? Okay, this one. Now the dotted. Okay, not visible. Now it is okay. Now the dotted part,
Universal set.
not the universal set. I'm considering about the dotted part only.
Union
A union B
A
complement.
whole
complement.
complement.
Yes. So the dotted part becomes A union B whole complement. Okay. And whole complement. Okay, remember in probability, complement is playing a crucial role. Okay, because we use this thing in finding out the answer to some problem. Where direct method will be crucial or tedious, then we use this complement manner. Okay, so there is a formula for A union B complement as well. We call it as in school level. Do you remember?
De Morgan's
De
theorem.
Morgan's law. Okay, so what is that De Morgan's law? A union B complement can be written as
A complement intersection B complement.
very good. The other one,
A complement, yeah. Union B
okay.
complement.
Simple thing you need to remember is that when this side it is union and it is having complement, then it will be the other side intersection with individual complement. Reverse, when it is intersection along with complement, the other side it becomes union with individual complement. This is De Morgan's law. Okay, and this is also very much useful in probability. Okay, in order to solve the problems. Any doubt, anybody? Hello, is there any
No,
doubt?
sir.
No, sir.
No, sir.
Okay, I am happy. Chalo. Why? I will not say. Next, make a heading. Write down. Symbolic notations. You need to understand, you need to remember these symbolic notations if you would like to understand the problems in probability. Okay, because most of the time the problems in probability are coming in terms of words. Okay, from words you need to think what you need to evaluate. Based on that you will implement the formula. Okay, so if you do not understand the problem, what you need to find out, obviously you will implement the wrong formula, you will get the wrong answer, ultimately I will give you zero happily. Okay, so you need to remember these things. Okay, write down, make the heading symbolic notations. Start. Let your capital S denote the set of sample space. Okay, let S denote the sample space of an experiment. Okay, and say if A and B, if your capital A and capital B are any two events of the experiment, then try to tell me the mathematical forms of the following terms. गलती होने दो. Let it be wrong. Don't worry. Okay? Do not hesitate. Okay? Do not hesitate. So the first one says the non-occurrence of the event A. How do you denote that in set theory?
A complement.
Yes, very good. A complement. So complement might be written as A dash, or you may write A C, or you may write A bar. Okay, but we will stick to this. Okay, these things can be used, but we will stick to this part. Okay, A complement means A dash. Okay, in the subsequent things, I mean classes, I will use A prime as the complement of A. Similarly, non-occurrence of B.
B complement.
Good. Let us proceed. Occurrence of next one. Okay, let me share the link here. Okay, you remind me every time. I will share the Jamboard link so that you can refer those things. Okay, so the occurrence of either A or B.
A union B.
A union B. Correct. Next. Occurrence of both A and B.
A intersection B.
Correct. In some books it is written as AB. Okay, it is understood. सिर्फ AB लिखा गया होगा. It is understood that it is A intersection B. Okay. Now answer this one. Neither A or B occur.
A complement intersection B complement.
A complement intersection B complement. Any other modifications?
A union
AB
A
whole
union
complement.
B
B
complement.
complement. A union B complement.
Both are same from the De Morgan's law.
Yes, sir.
Okay. So neither A or B occur. That means A union B whole complement. Or from the De Morgan's law, you may say A complement intersection B complement. Okay. Next. A occur and B doesn't occur. Now,
Only
okay. How do you say that? Only A. I will write in terms of only A. Okay. Then,
A
math.
minus
Tell me mathematically how do you write that?
intersection B.
A minus
A intersection B.
A intersection B. Okay. Any other modifications?
A minus B.
It can be
A
told
intersection B complement.
A minus B, or it can be A intersection B complement. Okay. Very good. You need to remember all these things. because you don't know in which problem which are the things given to you, or which formula can be done, or in which method or which manner will be convenient to you. Okay, for example, if the probability of A and A intersection B is known, then your thing can be evaluated through this. Okay, but if these things are not given, rather probability of B and A intersection B or A union B is given, then you need to come across this thing. समझ में आ रहा है नहीं आ रहा है?
Yes, sir.
I mean, all these things are equivalent. Okay, but one will not solve the purpose. You will have to use the things based on the things given to you. Okay, what is given to you? Based on that, you will have to think and implement the formula. Right. Okay, let us go to the next part. Suppose, similarly, you can do that the other way. I mean, A doesn't occur and B occur. That means A complement intersection B. Okay, I'm not going into that. Rather, let us extend the idea to 3 events. Okay, and the question is like this: all 3 events ABC occur.
A intersection B intersection C.
Okay, very good. Next, neither ABC occur.
Complement of A intersection B intersection C.
Is it A intersection B intersection C?
No, sorry, union.
Complement of A union B union C.
Complementary C.
Smruti, tell me. Smruti Ranjan, 848.
Yes, sir.
Tell me.
A complementary union B complementary union C complementary.
Come again. A complement.
A union B complement.
Okay, let me write. Okay, A complement, union B complement.
Union C complement.
Okay. Abhishekta, you want to say something?
Sir, I would say it's A union B union C whole complement.
A union B union C whole complement. Okay. Any other voting to any term? Any new?
The second one, sir.
Okay. Second one.
It's the second one.
Okay. Now debate. Smriti, give your justification to the first one.
Sir, it's neither A, B, C, nor so I guess.
Mm-hmm.
Sir, can
Swati,
it
you need
be
to
A
contradict.
complement intersection B complement intersection C complement?
Kunal, yes, tell me.
Sir, can it be A complement intersection B complement intersection C complement?
Yes, by De Morgan's.
Okay. So Swati, you need to debate on anyone?
No, sir. I'll go with both of them. Both of them are correct due to De Morgan's law.
No, no, no. You justify why it is correct. Your friend is saying something, you are saying something. Try to make him understand, otherwise justify. Explain the things why it is A union B union C complement. Why not A complement union B complement union C complement? What I mean to say is why this, why not this? Anyone like to elaborate?
Yes, sir.
Okay, go ahead.
Sir, first, sir, can you share your screen? Yeah. Sir, first I'll justify the second one, why A union B union C, because A union B union C is the total, and when we are doing complement, so it is neither one of it. And using De Morgan's, when we are doing the when we are opening that complement, so the union turns into intersection. The second and third are correct.
Second and third are same type, right?
Yeah.
Okay.
Sir, I can justify why the first one is wrong also.
Tell me.
Sir, if we consider the statement is given neither A nor B nor C. So the
Yes.
opposite will be either A happens or B happens or C happens, right? Which
Yes.
is A union B union C. And neither is A union B union C whole complement. Now in the
Hmm.
first expression it's written A complement union B complement union C complement. It means A doesn't happen, but B or C might happen, or B doesn't happen, but A or C might happen, and or C doesn't happen, but A or B might happen. This is my explanation.
Okay. Smriti Ranjan, is it okay now? And others. I hope this is a beautiful explanation. Okay. Because you have been told neither A, B, C, neither of them will occur. Okay. So you cannot take this one. Rather, the second will solve your purpose. Okay. And third one is just the De Morgan's approximation of that. Okay. Don't worry about it. Is it clear for everyone? समझ समझ में आया?
Yes.
So I'll write A union B union C whole complement. Okay. Or you may write A complement intersection B complement intersection C complement. Okay. Now, last thing. At least one of A, B, C occurs. What this will be then?
Sir, A intersection C union A intersection B union B intersection C.
Okay, just a minute. Can you repeat? A intersection C.
Sir, A intersection C union A intersection B union B intersection C.
Okay. Any other modification anybody want to incorporate?
Sir, if we take the previous statement A union B union C whole complement, and we take the entire complement of that, that will also, I think.
So at least one of ABC occur means what? Complement of complement. What is that?
That is the original thing, A union B union C.
Others.
Sir,
Yes.
so we can add up the individual and then we can subtract the intersection part and then finally we can add all the three, all the three, all the three intersection part.
Then
Like
what we got?
P probability of A plus probability of
There
B.
is no probability.
So
I am talking
probability.
about set theory. At least one of them occur. Anybody? This is not that much difficult. Come on. At least one of them ABC will occur. What does it mean?
At most, all will occur.
At least one means what? One or more than that.
More than that, yes, sir.
Okay, try to understand the logic here. The term or the question I have given or the term I want need to explain is this thing. At least. When I say at least one, it means one or more than that. When I say at least five, it means five or more than that. Are you getting? So here, at least one of them occur means directly it will lead to either A will occur, or maybe B will occur, or maybe C will occur, or it may be possible that all of them will occur. Okay, so it is A union B union C. ठीक है? And as for, I think, Abhishekta, you told na complement of complement. That way also it can be done, because in the above we have seen neither, and neither means A union B union C complement, and here we are putting at least एक तो हो जाए, at least one, so the complement, and hence it is A union B union C. That's the answer.
Sir,
Okay,
was
so
it
is it
wrong
clear?
that A intersection C union wala?
Very much complicated to understand that. Okay, maybe if you go through set theory, you can able to justify that yes, your answer may be wrong or may be right, I don't know, but the simplest one is this. Okay, so all of you try to remember these terms along with the notations. If you do not understand the notation, you cannot able to, I mean, think what you need to be solved or what you need to find out. If you cannot do that, things went wrong. Everything will get zero. Okay, everything becomes void. याद रहेगा?
Yes, sir.
Yes, sir.
Okay, all right. Okay, I was thinking to solve some problems, but anyway, no worry. Have I shared you the soft copy of the books? No. Yes or no?
No, sir.
No, sir.
No, sir.
No, sir.
No, sir. Okay. So I will share the soft copy. Have you got from the university any soft copy?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
Yes.
sir.
Fine then. That is your textbook. Okay. Okay. Can you see the PDF here?
Yes, sir.
Yes, sir.
Yes, sir.
This one is your textbook. Probability and Statistics for Engineers and Sciences by J.L. DeVore. Okay. And you will get the questions in your exam from this book only. Okay. This is a very nice book, and so many questions are given from this book. I mean, so many questions, varieties of problems are given. Okay, and examples are also discussed. So you can refer this. Okay. Thing that I need to say here over this is that overview of descriptive statistics I have not discussed. I will discuss this thing. Okay. I have directly started the probability part. That means we are in chapter 2. Okay. Here we have probability. Okay, and I am discussing the basic concepts already discussed. Sample space examples are there. If you want, you can go through these things. Events, simple events, compound events. Okay, examples of those, and then relationship of set theory along with union, intersection, and all those concepts were given. Okay, and here it is Venn diagram as well. So maybe okay, you might have another class after this.
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
very good. So in the next class we'll discuss this. Okay, exercise 2.1, right?
Okay,
We'll
sir.
discuss some problems and then we come to the